2.6 combinations of functions and composite functions. The first thing that we have to understand before we do combinations or composites is we have to understand how to find domain. I talked about that last semester, but I'd like to rehash a couple things. Finding domain. Remember, these are like all the x's that could be an input to your function that would give an output that makes sense, that is defined, that's an actual number. Okay? So, for now, granted there are more things than this, but for now, there are two things that cause problems with domain. You guys remember what they are? Division by zero. You can use your imagination for the other one. Basically, yeah. And how would you, what's probably the easiest way to generate an imaginary number? Well, yeah, it is I, but it's taking the square root of a negative number, right? So, and it doesn't necessarily have to be just a square root, it's got to be an even root. So like a fourth root would also be bad. So even roots of negative numbers. So those are the things that you're looking for when you're trying to find the domain of a function. If it has any of those are the things you have to avoid. If it doesn't, then generally speaking, the domain of your function will be all real numbers. So let's do some examples. Let's say that f of x equals x squared minus 7x. I'd like to consider the domain of f. So I look at my problem spots, right? Division by zero, even roots of negative numbers. Is there division? No. Is there a square root or a fourth root that's in the equation already? No. So if there's no division and there's no even root, there's no problem. What's your domain? Other way around, but yeah, negative infinity, positive infinity. Because there's nothing I have to avoid there. I can pretty much take any x I like, plug it in, and get an output that's an actual number. Make sense? I hope. So let's look at g of x. Thoughts? You've got division. So we would have to figure out where division by 0 occurs. What would probably be the easiest way to figure out when division by 0 would occur? Dakota, you got anything for me? Give me something, anything. I don't even care if it's right. If you had to figure out where this bottom part was equal to 0, how would you do it? Well, that's a thought. It's a wrong thought, but it's a thought. Yeah, if I set it equal to 0, but then how could I solve that? Yeah, why don't we factor it? Yeah, that's perfect. So how does this factor? So x minus 3 and x plus 1. Good morning, Nelson. That's totally on video, Mel. You're welcome. So, anyway, so where would that be equal to 0? Right, so you would have 0 on the bottom when x is 3 or when x is negative 1. You don't want that because division by 0 is bad. So I know that I don't want 3 and I don't want negative 1. The question then becomes, how do I write that? Careful. That's better. If you can put your problem spots in order, the easiest way to think about it is you go negative infinity to your first problem spot, union your first problem spot to your second problem spot, union so on and so forth until you hit the last problem spot, which we only have 2. So then you do the last problem spot to infinity. Do I need to draw a number line to illustrate why that works the way it does, or no? The silence is deafening. We're good? Okay. Let's get a new page. All right. So what about this? Yeah, you got a square root. And so we have to worry about, yeah, that's funny. We have to worry about taking the square root of a negative number, right? So the idea is this piece right here, whatever this is, I have to make sure that doesn't go negative. The easiest way to do that is to take 3x plus 12 and set it greater than or equal to 0, because if it's greater than or equal to 0, it's not going to be negative. So then all I got to do is solve this. Go ahead. This is the easy part. Yeah, subtract 12. 3x is greater than or equal to negative 12. And divide by 3. Whee! X is greater than or equal to negative 4. So I would write that as how? And again, if you have to draw a number line to figure that out, that's not a big deal. It takes, what, 10 seconds? If that 10 seconds is the difference between getting the problem right and getting the problem wrong, isn't 10 seconds worth it? Okay, let's do a few more of these just to make sure we got it, and then we'll move on. Let's see, what did I just do? 8? Let's do A. We never do A, do we? So A of x is equal to 5x over x squared minus 49. Somebody other than Paige, what are our thoughts on this one? Division by 0, right? All right, so let's factor the denominator. What does the denominator factor into? I like to use this sort of thing a lot. All right. So what are the spots I need to avoid? Yeah, positive 7 and negative 7. So x cannot be equal to plus or minus 7, but I need to write that as an interval. So the domain of A, that looks like a cube. Let me fix that. Would be equal to somebody other than Paige? Thank you. All right. Very good. How about, does anybody need more time on that page? Hey, keep an eye on my time so I don't run out of video. Anyway. Let's see. Crap, I lost my place in my notes. B of x is equal to the square root of 27 minus 9x. What do we think? Yeah, it's got a square root, right? How did we handle that before? All right, so take the radicand and set it greater than or equal to 0. The radicand is the thing underneath the radical. I mean, Valentine's Day is coming up, so I mean, you could be like, I'll be your radical, be my radicand. So, on that note, now that everybody is completely and utterly distracted, it works like this, right? I'm such a dork, right? How does this work? Yep, you got to flip the inequality. So x is less than or equal to 3, so the domain of B, I got less than 10 seconds, negative infinity to 3. Woo!